Alright, so today we're going to get into how to use the Pythagorean Theorem. This is going to be kind of in lieu of the notes, the traditional notes we do in 3.2. This is something a little bit different, so I'm going to kind of make my pen here a little so I can fit all my writing in here. So we're going to start up here in the corner. And again, if you want to color the star border in, you can, and even the words. But it says here the Pythagorean Theorem is for, and you're going to write adding the length of the missing side in a right triangle. So we use the Pythagorean Theorem to find the missing side. I'm sorry, that shouldn't be. It got hole punch. It's finding the missing side. So erase adding. It's finding. And there's my thick words. Okay. Finding the length of a missing side in a right triangle. Okay. So again, you can color in the Pythagorean Theorem here. Alright, the legs, remember? This is a leg of the hypotenuse. It's the shortest leg, which means it's what letter? A, B, or C? A. So this is A. The other leg is where the right angle connects to, right? So it's right here. This is the other leg. This is the longer leg, which is side B. Okay? And then, of course, side C, which is a diagonal, is called the hypotenuse. Side C. And side C is always the longest side. All right. And then over here underneath the star where you guys were at, Pythagoras was. He was a Greek philosopher. And mathematician. Had to remember how to spell mathematician there for a minute. Who is credited with proving the Pythagorean theorem first. He was the guy who discovered it, Pythagoras. So he was a Greek philosopher and mathematician who is credited with proving the Pythagorean theorem first. Give you guys a second here to catch up on the notes. So while you're taking a second to catch up on the notes, we're going to pause this. Alright, now we're caught up on the notes. We're going to move this down a little bit here. We're going to work on these little squares. So if you see here, you see the right triangle here, the 3, 4, 5 triangle. Right triangle. And you see the squares that are off it, right? And this is kind of what we did with in 3.1, right? Building the squares off the right triangle to show that. So it says here, use two colors in the square grids to show that the Pythagorean theorem is true. So I don't know, I'm just going to use green here on the 3. So I'm going to color in as best I can with the smartboard. I'm just going to shade in this green square here, the 3 by 3 square. Because this has an area of 9, right? You see the 9 blocks? And the square root of 9 is 3, hence why this little side here is 3. I don't know. I'll even put a little color into that. How's that? Not going to spend all my time coloring, though. Alright. And then below is the 4. So as best I can, of course, you kind of see it gets cut off here, but I'm going to use a different color to shade in the 4, because on your note sheet you can see that there's 16 squares here. So that square has an area of 16, which makes the side length 4. Okay? And now, again, the theorem states that the sum of the squares equals the, well, if you notice here, our 3 by 3 kind of fits in right here, right? I'm going to stay within this 3 by 3 square here in the middle. Just coloring in these 9 squares here in the middle. Yep, you do color that. All right, so it's hard to stay within the lines in the smartboard. And then the outer ring of the squares, I'm going to color it blue because it's combined with the blue square. So the green and the blue square make this multicolored square, which gives us an area of 5. Because 3 squared is 9, 4 squared is 16, 9 and 16 is 25, which happens to be what 5 squared is. And that's how this works. So you can see how this square and this square combine to make the hypotenuse. Nice little colorful visual. And again, if you don't have pencils or anything here today, or can't, you can color this later. Okay, if you want to leave it in black and white. But again, I can tell you this: your brain reads colors, so get things to stand out. All right, the Pythagorean the theorem only works on what kind of triangles? Right triangles, correct. I won't say right because that'll be right. And if you want to color like example 1, I don't know, like you can see, she's kind of colored it in and made the words a different color, just getting it to stand out. But it says, all right, a right isosceles triangle has legs of 6 meters long. Find the length of the hypotenuse to the nearest tenth of a meter. So by using the formula, I'm gonna bump this up a little bit just so you guys in the back can see here. So and I'll scroll it up. All right, so here's our. So that means if it's a triangle and the sides are 6, okay. So the 2 legs are 6. So you're gonna say a squared plus b squared. So because a and b are both 6, because that's what it says here, the legs equals, and we got to find the hypotenuse, c squared. So 6 squared is what? 36. And 6 squared is 36. So when I add 36 and 36 together, I get 72. All right, and now to get c by itself, I have to isolate c. I got to take the square root of both sides. So when I square root c squared, I get c. Because c times c is c squared. Just like 5 times 5 is 25. So the square root of 25 is 5. The square root of c squared is c. And then we're going to, again, both sides. So I'm left here with the square root of 72. Now, it said to the nearest tenth, right? Which means they want us to find this value of the square root. Is 72 a perfect root? No. So you come up with 8.4852. So 8.5 is our answer. 8.5 what? Meters. Okay. This is not a square because we're not talking about area here. We're talking about the length of one side. So it's just meters. So 8.5 meters would be our answer. Okay. So this is kind of the top half. Again, those of you just coming in, you can easily catch up with the notes. It's not we're gonna have lots of time. All right, so I got to change screens to go to the bottom of your page. Okay. So just give me 1 second here, and you guys come in and can just play catch up here. All right, there we go. So there's the bottom of the page, right? So we'll start here with the theorem. And the theorem is what you can color in, and of course a squared plus b squared equals c squared. This whole thing right here is the basis for what we are going to do. You don't have to box this, by the way. You can color it in, all right? But it says, here's what each letter represents. A and B are what? The legs. A and B are the legs of the right triangle. And C is the hypotenuse. Got to know the terminology.
Make sure you get down the notes first and
So,
then worry about coloring.
So here, in example 2, which we kind of, you can color this in later. But now, if you notice, we're given the hypotenuse, and we're given a leg, and we have to find the other leg. So this leg here looks like which side, A or B? Because it's smaller, right? And A is the smallest leg. So we are going to solve, and they made this x. I mean, whether you write a squared or x squared, it doesn't matter. We're gonna keep it with the formula. So a squared plus 8 squared equals 13 squared. And now we're solving for one of the legs, because that's what this formula does, is helps us find any missing side of a right triangle. Okay? Again, for those of you guys coming in, don't worry about playing catch up right now. Just go right where we're at so you kind of stay with us. So what is 8 squared? 8 times 8. 64. Anyone know what 13 squared is? 169. Okay. Now, just like we did in solving equations, right? We got to isolate our variable. So I got to take 64 and move it. How am I going to move 64 across the equal sign? Kelly. Subtract it. Got to do its opposite, right? To both sides. So when I do that, when I subtract that across, I'm getting a squared here is going to equal, this is 105. So again, to isolate A, what do I have to do? I have to do something to both sides. What do we do on the top one up here? Well, leg? Square root, both sides. So A, the missing side, is going to equal the square root of 105, which we need to find out the exact decimal. So if I plug the square root of 105 into my calculator, I get 10.246. So the 4 doesn't make us round up, so 10.2. And what's our unit of measurement here? No, feet. And again, it's not feet squared because we're not talking about an area, we're talking about an edge length. Okay? So you can see how we can find the hypotenuse, you see how we can find a missing leg. All right? All right, let's go to your second sheet, which looks like this. It says starts with try it in the upper corner. All right. So again, this is something again that you can kind of color in on your own time. So it says up here, it says find the length of the diagonal. Well, again, if I look at the diagonal, if this is a right angle right here, so is this. So if I go here, this part here, these are two right triangles stuck together, right? So I could find this side and this side. The diagonal ends up being my hypotenuse, my C, right? So I can do 4 squared plus 11 squared equals C squared. And C squared is my diagonal, which is what they want us to find, right? And this is in inches. So, what's 4 squared? 16. And 11 squared? 11 times 11. 121 equals C squared. And if I add 16 to 121, I get 137. So again, every time I get to here, I square root both sides. Taking the square root of both sides. So the square root of C squared is C. And that's the square root of 137. And if we take the square root of 137, you get 11.7 inches. So that means this diagonal right here would be 11.7 inches. Not too bad? Alright, so if we go to the other side, sometimes they give you what we call the converse of the Pythagorean theorem, or can we find if this is a right triangle or not? They give me three sides, right? How do I know which side is A, which side is B, and which side is C? Blake.
A is the shortest side.
Okay, A is the shortest side, so tell me where A is up here. Kelly? 8. Just put A up above it, just so you know. Where's B? 10, right? And then our longest side has to be C. So go ahead and take these and plug these in to the numbers. Over here. The stack, right by the stapler. There's all four of them there. So 8 squared plus 10 squared equals 16 squared. Alright? So the goal is this. The goal is this. I need to get the left side to equal the right side. If that happens, those are three sides of a right triangle. If my left side does not equal my right side, this is not a right triangle. And that's how simple it is. So 8 squared is 64. What's 10 squared? 100. 16 squared? I know it's a little high. You might have to put that in your calculator. Someone said something. I got my headset on. Sometimes it's hard to hear. 16 times 16. 256. All right, if I add 164, what do I get? So does 164 equal 256? No, it does not. So this is not a right triangle. No, this is not a right triangle. Nope, nope, nope. Because the left side doesn't equal the right side. So this is another form of a right triangle. I'm just going to slide this up a little bit. We'll get one more side here to do. There you go. So the little star over here. So the theorem works both ways. If a triangle is a right triangle, all right, then a squared plus b squared equals c squared. And if a squared plus b squared equals c squared, then the triangle is a right triangle. And we're going to do the last example on the bottom here in just a second. And then we're going to kind of help Darth Vader tie everything together here with a little video. Alright, so I'm going to pause this video just for a second so you guys can catch up on the notes here. Alright, so now that we're good, we are going to move on to the bottom of the page, which is right here. So this is the last part we have to do. So it says history. Although Pythagoras is credited with the first proof of the Pythagorean Theorem, used in what they call Euclidean geometry, it is believed that Babylonian, Mesopotamian, Chinese, and Indian mathematicians understood the concept before this time. So there are many proofs of the Pythagorean Theorem, including both algebraic and geometric. So our last example says, we can use this in a coordinate plane too. Find the distance between the points 4, -3 and 2, -1. Well, if I graph 4, -3, right? Remember, coordinate points x, y, right? So if 4 is positive, we're going to the right 4 and down 3, right? 4, -3. And then my other coordinate is at -2, which means we're going left 1. All right, so if I draw a line, we have to find that distance. Well, I can do it one of two ways. I can help draw in the other sides of a right triangle by going either this way, or if you prefer, this way. Either way is fine, right? Because either way has the same sides, right? Would you agree? This side here has a length of 1, 2, 3, 4. And this side has a length of 6. So I could use the two sides of this triangle this right triangle, to find the length of the side, the length between those 2 points that we needed to find, right? With me on that? Now, whether I did it, I did it this way, up here, this would just be 6, and this would be 4. Still the same thing, right? So 4 squared plus 6 squared is going to equal c squared, because our diagonal is always the hypotenuse. So 4 squared is, and 6 squared is, so 16 and 36 is 52. And then again, to isolate c, I do what? Take the square root of both sides. So the square root of c squared is c, and the square root of 52 is about 7.2. Now again, this is basically units because we don't have inches or feet up here in the problem, right? So we can leave that c equals 7.2. And that completes the right triangle. Alright, so now that we have our notes complete, I'm going to unplug my headset, but we're going to continue to roll here because we're going to show you this video of Darth Vader doing the Pythagorean Theorem. We'll get you one. Alright, so stay tuned here. So we're going to take this. We're going to fire this thing up here. Turn the volume up just a little bit. Alright, here we go.
Good morning, class. Today I will be teaching you the Pythagorean Theorem. It is your destiny. We begin with a simple right triangle. If we know the lengths of sides A and B, we can calculate the length of side C, the hypotenuse. The hypotenuse is the long side of the right triangle. But I prefer to think of it as the dark side. Don't underestimate the dark side of the triangle. To find side C, you are free to use any methods necessary, but no dissimulation. The Pythagorean Theorem states that the sum of the squares of the two short sides equals the square of the hypotenuse. A squared plus B squared equals C squared. All too easy. Let's look at an example. The side A is 5 centimeters long, and side B is 12 centimeters long. A squared plus B squared equals C squared, according to the Pythagorean Theorem. Take the square root of both sides.
He's just going in a different order.
So the square root of 5 squared plus 12 squared equals C, the hypotenuse. 5 squared is 25. 12 squared is 144. The side is long in this one. Square root of 169 equals C. I have you now. 15 equals C. The circuit is now complete. The hypotenuse of this triangle is 13 centimeters long. Impressive. Most impressive. Just remember, kids, don't be too proud of this geometrical terror you created. The ability to calculate the length of the hypotenuse is insignificant next to the power of the force. Vader out.
Alright, and then our second one is,
Please don't put on that wrap.
Please don't.
well, yeah, we're putting it on for the, so we can record the video here. So here's the song you'll never forget.
Too many crew are here to help you today with the Pythagorean Theorem. Enjoy the rhymes.
In a right triangle.
Listen to the words, though, because it's coming all the vocabulary they use in here deals with all the notes that we just did. So try to listen. I know you heard it yesterday, but try to really listen hard to the words.
The longest side squared, hypotenuse, wow. So A times itself, A squared and B times itself, B squared and C times itself, C squared, A squared minus B squared equals C squared. A long time ago, young in ancient Greece, a man named Pythagorean, he added a piece of little bit of history we still use today, the Pythagorean Theorem, and this is what we say, what he found out. A pattern he saw in a right triangle. There was a lot, then two squares formed on the shorter sides. Pieces set together is what he decided.
Starting to make some sense.
The longer leg line named hypotenuse. It works every time. So, for example, we'll tell you what now. 3 squared plus 4 squared is 5 squared. Pow!
How many squared?
3, 4, 5 triangle.
9 what we get was all simply 4 times itself 16 what we get. The sum of a square 25. That's
In a right triangle.
You just found the missing leg side.
And hard squared as it's all you do. And what do the equal will tell you now? The longest side squared hypotenuse well.
So A times itself, A squared and B times itself, B squared and C times itself, C squared, A squared minus B squared equals C squared.
What if I know the longest side's length and the shorter leg? I'll use my math strength, square the hypotenuse, subtract leg squared, square root the difference if you dare.
another example. We'll give you some. Longest leg 10 equals shorter 1. 100 minus 36 we get. Root 36 is 6 little bit.
So A times itself, A squared and B times itself, B squared and C times itself, C squared, A squared minus B squared equals C squared. In a right triangle, this is always true. Square the shorter legs, add, that's all you do. And what do they equal? We'll tell you now. The longest side squared, hypotenuse, wow. So A times itself, A squared and B times itself, B squared and C times itself, C squared, A squared minus B squared equals C squared. A times itself, A squared and B times itself, B squared and C times itself, C squared, A squared minus B squared equals C squared. No! Out! Hey!
All right.